My name is Silke Schlichting. I'm a postdoctoral fellow here at UCLA in the Earth and Space Science department. And my main research interest is trying to understand how planets form. And those are planets in our own solar system and the large number of extrasolar planets that have been discovered around other stars. I'm interested in small objects, especially at the outer edges of our solar system, so beyond the orbit of Neptune, because they're kind of one of the most primordial bodies that we have in the solar system. So they really are a relic from the planet formation phase. And so by studying them, it kind of gives us a constraint on our planet formation models. Recently, by having found a large number of extrasolar planets around other stars, and having learned that the architecture of those planetary systems often look very different from that of our own solar system, this has challenged our standard paradigm of planet formation, and so there's still many open questions and new questions that we have to answer. I do several different things. One thing that I do is I do a lot of modeling, and that involves trying to understand, for example, a certain process in planet formation itself, so then I can try to model that process by mathematical equations, and I can solve them analytically and numerically. But for example, I also do some component of my research that involves observation. So I take data with a Hubble Space Telescope, and actually I analyze this data to search for very small objects at the edge of our solar system. We try to probe the very smallest objects that we can possibly probe in the Kuiper belt by using stellar occultation. So what does it mean? It's basically these objects are so small that they don't reflect enough sunlight back to the observer. So instead of seeing them directly in reflected light, what we do is we kind of monitor a large number of background stars and wait for an object moving in front of them by chance. And then by dimming a little bit of that stellar light of the background star, we can infer that objects are there. And so by studying these objects and by understanding how many there are of these objects, we can understand whether our Kuiper belt is undergoing a stage of collisional grinding, because that would change the abundance of those objects. If they collide and are being broken apart, there will be fewer and fewer of those bodies. By studying these objects and constraining their abundance, we can kind of infer whether or not our Kuiper belt is really a true analog of debris disks, that are dusty disks that we see around other stars. And I think we made a lot of progress in that direction, and it does look like that our Kuiper belt is indeed one of those debris disk analogs for our own solar system. So I think that was exciting. Yeah.